Alright, here's the last video for Unit 8, 8.5, the trigonometric application. So it goes off of the last unit, which we had 8.4 and 8.5. So here's the more trig applications. So we went over that the angle of elevation is the angle formed by the horizontal line of an observer's eye, line of sight, here it is, looking above that horizontal line. Which means that the angle of depression formed by the horizontal line from that observer's sight looking down. So it's below. So when we're looking at these pictures, in this one, what's the angle of elevation? So the angle of elevation is angle TSL, and the angle of depression is angle FLS. From the moose up here, the angle of elevation is angle ABC, looking up. The angle of elevation is, depression is DCB, over here. And lastly, the angle of elevation, reversed it, angle RPZ, and the angle of depression right here, WZP. That's the hardest thing, is to make sure that you are marking the correct angle so you can be able to solve these. Same rules apply to answer the following problems. Draw and label a picture, set up the equation, and solve for the missing information. Find the lengths, 2 decimal places, and the angles to the nearest 10th degree. Show all of your work. So we have some pictures here. We have a skier. The ski run is 1,000 yards, so that's here. Already labeled in the picture. The vertical drop is 208. They're trying to find the angle of depression. So the angle of depression is right here. Here's the issue, is that in my triangle that I just drew, in my right triangle, it is not. So we learned that this line is parallel to this line back in first semester. Parallel lines, these are called alternating interior angles. Alternating interior angles are congruent, so now we can find that angle of depression for that skier. So what do we have? So in the triangle, here's the opposite, hypotenuse, adjacent. So SOHCAHTOA comes back into play. We have the O and the H, so we have the sine of the angle is equal to 208 over 1,000. So you hit the inverse sine button of 208 divided by 1,000. Get the calculator out. We got inverse sine 208 divided by 1,000. Enter. That angle is 12.0 degrees. The angle of depression. Okay. Example 3, the length of the loading ramp. So we have the picture here. Here's my right triangle. The length of the loading ramp is 15 feet. So the 15 is here. It has a height of 3 feet. What's the angle of elevation? Here's the angle of elevation. So let me just draw it a little bigger for you. Looking for x here. Length is 15. This is 3 feet. So looking at our triangle again, opposite, hypotenuse, so there's a right angle, adjacent. So it looks like we're going to be using the sine function again. Sine of the angle measure is equal to 3 over 15. Calculator out. Inverse sine. 3 divided by 15 equals approximately 11.5. Angle of elevation. Moving on, we have a ramp to a parking garage is built with a ramp angle of 25 degrees. the end of the ramp is 35 feet from the base of the garage. So the base of the garage, that's this bottom part down here. So that's the 35 feet. Down here, you have that angle of elevation in 25 degrees. They want to know what is the length of the inclined surface of the ramp. So they want to know what is this right here. So we could do our opposite again, H, A. So this time we have the A and the H. So finally we're not using sine, we're using cosine. And we have the angle measured. And we got the adjacent over the hypotenuse, which is x. Variables in the bottom, so we said interchange these two. So you're going to go to your calculator and do 35 divided by cosine of 25 degrees. 35 divided by cosine of 25 degrees. Enter 38.62, rounded. 38.62, and we're talking about feet here. Is the length of the ramp. The next one says, write a word problem that can go with the picture. So, I mean, you could look at a bunch of things and you could say, hey, the observer has an angle of elevation. He's looking at a person that is 3/4 of the way up from the Ferris wheel. You can say that the person on the Ferris wheel has an angle of depression looking down towards there. Here's the height, or here's the distance away from the person is from the Ferris wheel. So you can say a ton of different things here. It's however you want to write it. So you write it and then present it to the teacher for credit when you do the notes. The backside. So we have 6 questions down here and we're done. So we have a surveyor. Here's this guy. So you've probably seen him on the road. And they're checking signs and different distances. They're standing 100 meters away from the building. So in this case, there's the guy standing away. Here's 100 meters away from the building. He says he's got an angle to the building is 33 degrees. What is the height of the building? So here's x. So from the 33, here's the opposite side, here's the hypotenuse, here's the adjacent. So we have the O and the A as ptoas, so that's the tangent of 33 is equal to x over the 100. So you're going to go to your calculator, you're going to add 100 times tangent of 33. That's going to equal x. So we got 100 times the tangent of 33. Enter, and it looks like the height of the building is 64.94 meters. The height of building. And I always want to make sure that you're addressing what the question is asking. Ooh, could be depending on how you're watching this. As I'm making this video, this is football season, so the stadium here, it's always soccer season around. So no matter what you have here, you have a stadium filled with people. The altitude is 800 feet for this blimp, so 800 feet. It's hovering above. The radius of that stadium is in the cylinder, so the radius of that is 1,200 feet. What is the angle of depression? Well, here's the blimp's line of sight, so the angle of depression outside here, with that parallel line idea again, it'll convert down here. Okay, so we're looking at a triangle. I drew it bigger over here. Okay, Whoops. So here's the triangle, 800, 1200, angles down in the bottom here. So here's the O, the A, and the H. So it looks like, again, we're doing the tangent, this time of x is equal to 800 over 1200. So the inverse tan, 800 divided by 1200. So if we go to our calculator, inverse tan 800 divided by 1200, enter, rounded the nearest tenth, so 33.7 degrees. Next one, we have a 4-foot wire set. So the 4-foot wire set, this length here is 4 feet. It has an angle support of 55 degrees. It is 6 feet below the top of the tree. So from the top of the tree, 6 feet below that, so this is 6 feet. It's not in our play. And we need to know how tall the tree is. So we can find this length right here from my triangle. So if we're using the triangle correctly, we can say here's the O, here's the A, here's the H. So we need this side here, O and H. So we have the sine of 55 is equal to x over 4. And we're doing 4 times sine of 55. So 4 times sine of 55. You get 3.28. But that's this piece right here. We want to know how tall that tree is. So that's 3.28. We're going to add that 6 feet on, and we're going to get 9.28 feet height of tree. So you had one extra step at the end there to make sure that you did. Be careful, otherwise you're going to get these questions wrong. Not just on here, on SAT and different things like that. So the contractor leans a 19-foot ladder up against the side of a building at a safe angle of 65 degrees with the ground, where the contractor will be able to reach a repair that's 17 feet up the wall. So like we have to see how far will this ladder reach up the wall. Okay, can it reach that 17 feet? So we're going to call this the question mark. So this is our x. So from our picture here, we have, this is the opposite, this is the A, this is the H. So we have the O and the H again, so we're going to do sine one more time. 65 is equal to x over 19. So 19 times sine of 65 is going to give me x. So 19 times sine of 65 equals 17.22. So the ladder reaches up 17.22. It says, will the contractor be able to reach a repair that is 17 feet up in the air? I would say barely. But will reach. Since ladder reaches 17.22 feet against the building. Okay? So it's close, but they'll be able to do it. Last but not least, these two questions here at the end. So we got a sailors on a ship at sea spot a light from a lighthouse. The angle of elevation to the lighthouse is 25 degrees. Here it is. The lighthouse is 30 meters above sea level. How far from the shore is the ship? So down here. So here's the O. Here's the A. Here's the H. So we have the O and the A. So we're going to be doing the tangent of 25. is equal to the O, which is 30, over the A, which is the X. Here's the one where we can interchange these. So we're going to go to our calculator, do 30 divided by tan the 25. 30 divided by tan 25. And we're going to get 64.34. And we're looking at meters from the shore. Okay. Last but not least, we have the airplane, the control tower. The control tower is 120 feet tall. It says it has an angle of depression, so outside, but we've learned that parallel line rule makes that 19. Notice that the angle has always been down at the bottom of the triangle that you've drawn. Okay? And we want to know how far from the base of the tower, so we're looking for down here. So the last time we're doing this, we have, this is the O, here's the A, here's the H. So it looks like tangent one more time. So we got the tangent of 19 is equal to 120 over X. Interchange these two again, so you have 120 divided by tangent of 19. 120 divided by tangent of 19. And end up with 348.51, and we're looking at feet from the base of the tower. Well, that takes you to the end. You have a couple more things, and I just want to wish you good luck on your test for this unit.